What we're going to work on today is learning how to resolve composite functions. Now, part of the problem with dealing with functions is that oftentimes we use the function f of x or g of x, which is completely unintuitive. So let's start our lesson with functions that have names. So let's say that I was going to create a formula to compute how much money I owed you from your salary. So let's say that I pay you $10 per hour plus $5 for parking. So if you work 3 hours for me, I plug in 3 here, then I would owe you 10 times 3 plus 5 equal 30 plus 5. I would owe you $35. Now, this right here is the name of the function, and this inside right here is the parameter. Now, it's important to understand that this is not a multiplication. This is not salary times hours. This is plugging in hours into our salary formula. Now, similarly, I could create another function. I could name it benefits. So let's say that the state required that for every hour you worked, I pay you $3 an hour for benefits. So if I wanted to compute how much you cost me for working 3 hours, I could write it like salary times 3, not times 3, but we're going to plug 3 into salary, plus we're going to plug in 3 into benefits. And then I could compute how much you cost to the company by then plugging 3 into each one of these functions separately. So I would get 10 times 3 plus 5 is equal to plus 3 times 3. Okay, so this would tell me how much I would owe you for benefits, and this would tell you how much I owe you for salary. I'd get 35 plus 9 is equal to 44. Now, part of the problem with this notation is that I could make a mistake. Notice that I want salary and benefits to have exactly the same parameter being plugged into it. In that case, there's a different notation. So this is legal notation, but a notation that sort of protects me from writing a different number in here than in here would be the following. Salary plus benefits. Okay. Now what this notation is what I want to do is I want to plug in 3 separately into salary and benefits. And then once I figure out what the value of those functions, I then want to add the results together. So basically this then turns into that. And then we will go on and finish the problem like that. So the strength of this notation is that it ensures that both salary and benefits have exactly the same parameter. I don't have to worry about mistyping it. Suppose you had 100 of these functions that you were adding or subtracting together. You could easily see how one of them might have a typo, and this protects you from doing that. Now, if I wanted to create the expression for what your cost is to the company in a general form, what I could do is I could start my problem like this. Oh, sorry. Okay, I can say, well, in order to compute your cost, I figure out what your salary is and I figure out what your benefits is for a particular number of hours. And then I would plug this, and then this would turn into and then I would then substitute this expression for salary. And then I would substitute this expression for hours. And then if we combine like terms, we would get 13 hours plus 5. So if I wanted a formula to compute how much you cost the company, all you would have to tell me is hours, and I would just plug it in here. So you could solve this both for a particular number of hours, or you can find a general expression by just plugging in a variable. So we'll use some unintuitive but mathy names like f and g. So the function f of x is equal to square root of x, and the function g of x is equal to x plus 2. So if I'm trying to figure out what this is, if I'm trying to expand it, I'll first apply this parameter to both functions. And then we'll say, well, what is f of x equal to? Now, anytime you do a substitution, whether it's a number or if you're substituting a function with its expression, always put a parentheses around it. Sometimes it matters, sometimes it doesn't. In this case, it doesn't. And then that's your answer. Now, we can also do it for other operators like minus or times or divide. So in this case, if we have f divided by g, we do the same thing. We apply the parameter to both functions. And then f of x is equal to square root of x, and g of x is equal to x plus 2. And basically now you're done. Now, if I put a number in the parameter, we can apply the parameter to both functions. And then we can then figure out what f of 9 and g of 9 are separately and then add them together. So f of 9 is equal to square root of 9, right? I'm just plugging in 9 wherever there's an x. So then that's equal to 3. And then g of 9 is equal to x plus 2. So that's equal to, 9 plus 2, right? We're substituting the x with a 9, so then we get 11. So when you add the results of f of 9 plus g of 9, I get 14. Now we're going to work on what's called composite functions. Composite functions are functions that call functions. Now it looks terrifying, but it's going to be okay. Now the first thing we want to do is we want to go inside out. We want to substitute for g of x. So we can see over here that g of x is equal to x plus 2. Okay. Now, it's a little terrifying to see. Now we could see that when, let's say I had given you a number. If I had asked you what f of 2 is, most people would be comfortable to say, oh, that's just square root of 2. Now, all we're doing is pattern matching. So if this is equal to this, then if I put an x plus over here, then that should be the exact same thing over here, right? All we're doing is replacing this x for what its parameter is. So this will turn into, and then we're done. Now, just know that there's a secondary notation for composite functions. This is absolutely legal, but you could also write this as f of g of x, which means plug in x into g and then plug in that result into f. You go right to left. So in this case, we're going to start with this composite function notation, right? So that's not a multiplication, that's a composite. It's just an open circle in the middle. Now, let's transform this notation into this notation. So we'll go right to left, and we'll get g of f of x, and then we'll replace f of x with, what is it defined to be? Square root of x. Okay, and then we're going to use g of x as our template. Anywhere there's an x, we're going to put parentheses. And what goes in that parentheses is our parameter. and then we're done. Okay. Now, we can also do composites with numbers in the parameter. So again, we go right to left. I'm going to plug in 7 into G. And then I'm going to plug in G of 7 into F. Okay. So first let's figure out what G of 7 is. G of 7 is equal to, if we plug in 7 here, so I can place G of 7 with 9, and then if we plug in 9 into f of x, we'll get square root of 9 is equal to 3, and that's my answer. Let's try this again. So again, we go right to left. We're going to go G of f of 25, right? This goes into f, and then that result will go into G. So let's figure out what f of 25 is. It's equal to 5. So now let's put in 5 in for f of 25. We're going to get G of 5. So now this turns into, anywhere there's a x, we put a paren. And what goes inside of that parentheses is 5. So this is 5 plus 2. Oh, I should finish that and say 5 plus 2 is 7. Okay. Now, let's do the last little bit of this. So go ahead and freeze the video, and these are the 4 different ways I can give you the problem. And I've given you a different given for the functions. Okay, now that you've tried this out, let's work on this together. So for over here, we have a composite. We're going to plug x into G, then G into F. And we can see that G of x is equal to 2x plus 1. And then we're going to use f of x as our template. Anywhere there's an x, we're going to put a parentheses and then a square. And what goes inside that parentheses is 2x plus 1. And I'm fine with you leaving that as the answer. You don't have to FOIL it. Now we can also do composites with a number. Again, we go right to left. We go G of f of 2. Right? This goes into here, and then that goes into there. Let's figure out what f of 2 is. So if I plug in 2 into f, I get 2 squared, which gives me 4. So f of 2 is equal to 4. Then when I plug 4 into G, anywhere there's an x, I put a parentheses. And what goes into that parentheses, I put in the number, the parameter. So I get 8 plus 1 is 9. Okay. Now these on the bottom are not composites. So this one turns into f of x minus g of x. We're applying the same parameter to both functions. F of x we can see is equal to x squared. And g of x is equal to 2x plus 1. And you can see in this case, if we don't put the parentheses there, we'll get the wrong number. So anytime you do a substitution of a variable or a function, make sure you have the parentheses. Sometimes it doesn't matter, and sometimes in this case it does. So we're going to distribute that negative to both of these. So we'll get x squared minus 2x minus 1. And that's my answer. In this case over here, we're going to apply the same parameter to both functions. We'll get f of 3 over g of 3 is equal to 3 squared over 2 times 3 plus 1 gives me 9 over 7. Well, thank you for watching this video, and if you found it helpful, please like the video and subscribe to our feed. Thank you very much.